CS1535. Today we are going to study physics module 3. Let's go on to the index. Wave particle dualism, de Broglie's hypothesis, matter wavelength properties, properties of matter wave, Heisenberg uncertainty principle, principle of complementary. We're going to study this. Wave particle dualism. The phenomena like interference, diffraction, polarization are attributed to the wave properties of radiation. The quantum theory of radiation and experiments like photoelectric effect and Compton effect describe the particular nature of radiation. Thus, radiation behaves like a wave and like particles under different suitable circumstances. Hence, radiation exhibit dualism nature. De Broglie hypothesis. In the year 1924, French physicist Louis de Broglie extended wave-particle dualism through the hypothesis stating if radiation energy could behave like one wave in some experiments and particle or the photons in the other, and since nature loves symmetry, then one can expect the particle like photons and electrons to exhibit wave nature under suitable circumstances. This is well known as de Broglie's hypothesis. Therefore, some sort of wave can be even associated with moving material particles called as matter wave or de Broglie waves, and the wavelength associated with the matter wave is called as de Broglie wavelength. The wavelength of photon in terms of the momentum is given by lambda is equal to hp. Hence by analoging the de Broglie wavelength of matter wave is given by lambda is equal to h by p, that is equal to h divided by mv. Hence m is the mass of moving particle and v is the velocity. Matter wave and its properties. The velocity with which a wave is travel is called as phase velocity, and is also called as wave velocity. If a point is if a point is marked on the wave representing the phase of the particle, then the velocity with which the phase propagate from one point to another is called as phase velocity. PV is equal to nu by K. E divided by P is equal to C square divided by V. Hence C is the velocity. Hence, C is the velocity of light in vacuum, and V is the velocity of matter wave. This it is also evicted from the above equation 3.1, that phase velocity is not only greater than the particular velocity, it is also greater than the velocity of light. Hence there is no physical meaning for phase velocity of matter wave. Wave packed and group velocity. Since the wave velocity of matter wave must be equal to that of the particle velocity, and since no physical meaning can be associated between the concept of velocity is introduced. This is the diagram which we have to draw. Matter wave can be considered as resoluting wave due to superposition of many components of wave whose velocity are different slightly. Thus, a wave group of wave packet is formed. The velocity of which the wave group is traveled is called as group velocity, which is same particle velocity. It is denoted by Vg and is a given in equation and is given in equation. Properties of matter waves. The following are the properties associated with matter waves. First property: the matter waves are associated between the particles in motion. Second property: they are not electromagnetic in nature. Third property: group's velocity is associated with the matter wave. Fourth property: as resulting the superposition of large number of components waves which is slightly different in frequency matter wave are located. Fifth property, the phase velocity has no physical meaning for matter waves. Sixth property, the amplitude of the matter wave at given point is associated with the probability density of finding particle at point. ಆಮೇಲೆ seventh property, the wavelength of matter wave is given by lambda h by ma. Heisenberg uncertainty principle. The stimulated determination of the exact position of momentum of a moving particle is impossible. Explanation, and according this is the statement of the Heisenberg principle. According to the principle, if lambda sorry delta x is the error involved in measuring of the position, delta px is the error involved in the measuring of momentum during the stimulate measurements, then the produce of corresponding uncertainty is given by delta x. Delta p is more or greater or than equal to h by 4 pi. This is the last equation you have to write. The product of the error is of the order Planck's constant. If one of the quality is measured highly accurate, then the stimulated measurement of the other quality becomes more or less accurate. Physical significance, according to the Newton physics, the stimulated measurement of position and momentum are extract, but the existence of the matter wave induced serious problems due to the uh, limits to accurate associated with the spontaneous measurement. Hence the exact hence the exactness in the Newton's physics replaced by quantum mechanics. Principle of complementary statement. Bohr stated as in a situation where the wave aspects of system is revealed, its particle its particle aspect is is conclave, and in a situation where the particle aspect is elevated, its wave aspect is concealed. Revealing the both stimulately is impossible. The wave and particle aspect are complementary. Explanation. We know that the consequences of uncertainty principle is both the wave and particle nature of matter cannot be measured simultaneously. In other words, we cannot precisely describe the dualism of nature. If an experiment is designed to measure the particle nature of the particle during this experiment, error of measurement of both position and the time coordinates must be zero, and hence the momentum energy and the wave nature of matter are complementarily unknown. Similarly, if experiment is designed for measuring the wave nature of the particle, then the error in the measurement of energy and the momentum will be zero, whereas the position and the time coordinates of matter will be complementarily unknown. Unknown form of the above explanation, we can conclude that when the particle nature of the matter is measured or displayed, the wave nature of matter is unnecessarily surprised and vice versa. Thank you. This is my roll number, class section, college. Thank you for watching my